vertical cylinder of base diameter 50 and axis length 60 mm is cut by two planes which are perpendicular to VP and inclined at 45 degree to HP, passing through either side of the center point of the top face. Draw the development of the lateral surface of the cylinder. So first we will draw XY line. Here in this problem we need to construct a cylinder here of diameter 50, axis length 60. Okay, so take compass, measure 25 mm from the scale. Okay, measure 25 mm from the scale and draw a circle. Okay, now we need to cut this circle into equal parts. Okay, first I'll be drawing a diameter horizontally and then vertically. Okay, now I will take a protractor and mark for angle 30 degree, 30, 60, 90 like that. I will mark 30, 60, 90, 120, 150. Okay, so now with the help of a scale I'll be drawing a straight line passing through this angle point on both sides. Okay, so it is totally cut into 12 equal parts, so that means 30 degree. 360 divided by 12 means 30 degree. Okay, here also I will draw a line passing through this angle point. The same way here also I will do. Here also for 150 degree. So I'll be drawing a line, angle line. Okay, so now you can give the naming A, B, C, D, E, F, G, H. So mention the namings. Okay, so you can show the dimension of this circle on one side. So diameter 50. Okay, now we have to project it upward to complete the front view. So front view will be an rectangular face. Front view of a cylinder, it will be a rectangular face. Okay, consider a axis length of 60 here. You can mention the naming in the front view. Which are the face visible, that will be written within bracket. So which are the faces not visible, that is written within bracket. Okay, here now we have to draw two planes, so which are perpendicular to VP and inclined at 45 degree to HP. So there are two section planes we have to do. So it is exactly from the center point of the top face. On either side we have to mark at an angle of 45 degree. On either side we have to do it. Okay, so draw now the section planes. Okay, so mention the angle 45 degree. Here also you do the same thing. Okay, and give the naming for the section plane where it is cutting with respect to the vertical edges. We will mention with the numbers here. Okay, so we'll start from 1 2 3 4 5 6 7 8 9 10 11 12. So we will extend this. So this is also drawn with the true length of line. So parallel edges, parallel line method it is. So we will extend from the bottom also. Okay. So we can take a first vertical edge from AB. You can measure that what we have cutted with respect to 30 degree, right? So we should cut it. So that is A point. So one length you measure and cut the number of arcs, because each of these arc lengths were same. Okay, from AB to BC, BC to CD, all lengths were same here. So you can mention the namings here. At the end also you mention A. Okay, now we draw vertical lines here. Okay, now we have to measure from the compass that points 1 2 3 4 is there, right? We should measure that. So measure all that 1 2 3 4 arc points, okay, from the compass and cut on the respective vertical edges. So again, so 8 9 10 points also, and you should measure that and cut the arc on the respective vertical edge. You can mention the naming. So now connect these all these 1 2 3 4 points with the curve here. We need to use curve here to join it. that completes the problem. So in this video we are going to construct a development of the cylinder. So cut it by section plane at an angle of 45 degree on either side. You can see we have to draw the development for this. So first I'll be drawing XY line VP HP XY, then drawing a circle for diameter 50 mm. Then we divide the circle into 12 equal parts, that is we'll take an angle of 30 degree here. So 30 degree, 60 degree, 90, 120, 150, 180, like that we draw, and then basing extend to next command. So we are going to extend these lines. You can write the naming for it. Show the dimensions and draw the projection lines from all these ends to draw the front view. So the outer lines will be thick lines, the inside lines will be thin lines here. So the front view of the cylinder is also a rectangular face. So constructing all the lines here. Okay, so show the dimensions. You can see we have to taking the top face center. We have to draw two 45-degree angle lines on either side as it is shown in the figure. Okay, for that I'll be drawing the front view of it. So drawing the front view notations here. So now I'll be drawing the section plane. So from the top face center by giving an angle of minus 45 degree this side, and from this side it is minus 135 degree. So I'll be making the upper part as a thin part, so we have to show only the lower part as the retained portion after the section plane cut it. So by selecting the upper part, I'll make the upper part as thin line here. Okay. Now for the cut plane, I'll be mentioning the numbers here. Okay, now I have to draw the parallel line here. Line had to be drawn parallel to the axis, parallel to the XY line here. Okay, now using offset command, I'll be giving a length of 157.08. Okay, you all know how to find out, that is pi d. Okay, so that is the formula to find out this value, pi into diameter. So we will get this exact length. Okay, now 157.06, so divided by 12 parts, so the length what we get here, it is, so you can see in the solution book, it is 13.09. okay, so that means we have to offset each of these faces for a length of 13.09 mm. okay, so go to offset, select any vertical edge and type it 13.09, enter, and then you can equally space them into 12 equal parts. Okay, now you can mention the namings here. So just draw horizontal projection line here. So this one, it is cutting on that vertical edge A here. So I'll be mentioning 1 on the vertical edge of A. Same way I'll be drawing the projection line of 2, and it is cutting on a B and L. So that is point number 2 and 12. So on the B I'll be mentioning 2, on L I'll be mentioning 12. Same way, so there is a projection line from 3 and 11 horizontally. So it is cutting on the vertical edge C and on the vertical edge K. Okay, now 4 we are getting on the extreme corner end. Okay, Okay, now we can mention the numericals here. 6 I have mentioned. Okay, 5, 6 and 7 we get at the 1, okay, on that one projection line, and then we have 8 and then 9. Okay, now from 1, 2, 3, 4, 5, 6, everything here it is should become joined with the curve here. You can see that curve, we have to use it here in order to join from 1 to 12. So I'll be using a curve command. Okay, the thickness is 0.50 mm thickness. You can zoom in and try to connect with the exact point here. Okay, that's what. You can zoom in and try to connect with the exact points. Seven, then 8. Okay. 9 we have. 10 we have. 11, 12, and then 13. So it is joining at the 13 end. Can see now. So this completes the problem. So you can subscribe for this channel and hit on the bell icon and the like button for the latest notifications, and share it to the maximum students so that they can be benefited. So the upper part of this, I'm making it as a thin line. Okay, so the cut part we should make it as a thick here. So thank you for watching the video. Thank you all.